So I was thinking it'd be a good idea to fill the ice chest with candy and hand out candy for Halloween with it. But then I realized a remote-controlled homemade ice chest with a flamethrower that randomly gives me blood presents once in a while is probably a really bad idea to do that. So I'll probably just drive it around and shoot some flames, but I'm not gonna let kids touch it. So I'm here with my ice chest, codenamed Icy Hot, and I'm going to give you guys a little walkthrough of all the technology, all of the things, components, and everything that I used to build it. So this is going to be maybe a technical video for some. Maybe you're not interested in that stuff. Maybe you are, who knows. But I'm going to tell you how to build your own flame-throwing ice chest that you can ride and is remote controlled. So here we go. I'm also going to try and explain some of the challenges, but for a lot of this, I'm probably going to be behind the camera, so whatever. Let's get to it. So what's really cool about a flame-throwing ice chest is the ice chest can be used as storage for all your cool things like batteries and controllers and other stuff you need to haul around. It's kind of neat. So the transmitter I'm using is the iFlySky I86 or i6S or something like that. I don't know, I'll try and put the name of this transmitter over the screen. It comes with its own receiver, which is buried in a bunch of wires. If you're gonna try and build something like this, you need to get a receiver with at least 6 channels on it, roughly, or 4 channels. The receiver you get needs to have channel mixing on it. And what channel mixing is, at least on this receiver, sometimes it does this, where this touchscreen just doesn't want to work. So channel mixing means, so with this one control stick, this would be moving up and down would be channel 2, left and right on this stick would be channel 1. See how if I go right, how both those channels go to the left. Now they go to the right, down, spins them around. So this operation would be make the cart go forward. So the wheels over here are inverted. So one is going clockwise and the other is going counterclockwise in order to produce a forward operation. And so in order to send those signals to your receiver, oh, come on. Oh, darn it. There it is, mix. So channel 1, you can see that the master is channel 2, slave is channel 1, negative 100%, positive 100%. I hate these touch screens, I really do. There we are. And for channel 2, I have channel 1 as the master, channel 2 is the slave, offset 0%, negative 100, positive 100. And so that just means that the controller will operate the way that I need it to operate. So enough about the dang controller. Now I got these bins from IKEA, and basically it's just so I can have the battery for the... Oh, speaking of batteries, you need a ton of batteries. So this is these are 3 6S batteries and then one little 11 volt battery. But this one is used for the solenoid. This one is used for the ignition, the taser, the flyback transformer. And these two together are wired in series with a bunch of little connectors that I made. Because I didn't want to spend the $5 for this particular series connector. So this piece here takes two XT60 connectors, wires them in series, and outputs them into a single XT60 connector, which is really not safe to use on its own because the spark generated by these two batteries is really, really, really big. and it will short out and carbonize your connectors immediately. And so because of that, so this thing will get them putting out the right voltage. But then on top of that, I need an XT60 to an XT90 adapter. So this takes this XT60 output, boom, and outputs it into an XT90 connector, which is much safer. It's an anti-spark connector, so your connectors won't carbonize and get destroyed right away. But you can see that even so, you will get a little bit of, maybe not. Where is it? I thought one of these had sparked up a little bit. Oh, there, I guess it is a little bit black in there. Either way, it's a much safer connector for use with much higher voltages. And this is a 12S pack that we're trying to wire to it. So what we do, or what I do anyways, is I take these two connectors, or these two batteries. One goes in there, another one goes in there. The other way though, here you see it's one's one way, one's the other way. Now we have 48 volts coming out of this little guy right here with two giant lipos. Now you gotta be really careful with lipos. They're like super dangerous. Each one of these lipos has the same stored energy as like a regular hand grenade. So whenever you store them, you want to put them in like a lipo safe bag. You get these like super cheap on the internet, and it's just an extra little safety measure just in case. And so we got another 6S, which is 22 volts. I'm using that to power a flyback transformer over there. We'll get to that in a minute. This little lipo here, this 3S lipo, that's just used to power my 12 volt solenoid. It doesn't have to be exactly 12 volts, as you'll see, this thing works just fine. But let's get to the brains of this operation. We've got a pencil box here. This is the most important component. We have an O drive. So this is essentially a beta piece of hardware and software. When I bought it, it was still even more beta than it is now. It's basically two motor controllers. It can take an insane amount of power. There's nothing like that on the market for this price. Like, you couldn't get two speed controllers that could handle that much battery for any cheaper than you can buy one of these things. So go get an O drive. There's a link to it in the description of this video. All the software is open source, and there's a huge guide on how to get hoverboard motors operating properly. It might take a little bit of messing around with it, but it's all documented, and there's a Discord, and you can talk to the guy that actually makes these circuit boards, the O drive, on his own Discord forum, and he'll answer his questions and help you get up and running. I highly recommend them. Getting it set up was extremely technical. These things are actually usually meant for like CNC devices, so big router tables and stuff like that. I mean, it works really great for these hoverboard wheels. And that's the same thing that William Osmond used on his shopping cart. So with 24 volts, this thing worked just fine. But once I bumped it up to 48 volts with two lipos, I noticed that the wheels started intermittently shutting down randomly. And also, once I added on the taser and the flamethrower and stuff over there, that every time I sparked it, the wheels would just completely shut off. And that's because up here we have Hall sensors. So our Hall sensors are plugged in to these ports here. There we are. The Hall sensors get plugged in up there, and they run on 5 volts. And the thing about these boards is they all operate on a common ground. And you have a little ground pin right there, which the receiver is plugged into. And so when I was using the taser ignition, that common ground that all these Hall sensors and the whole board and everything else is all freaking attached to, basically it would cause an interruption in those Hall sensors, and they would flip out and just shut off the motor, so I'd have to cycle the power. And I noticed on William's shopping cart, he has to cycle the power very frequently. And the way I found to fix that is by taking my little capacitors you see there. There we are. I took a bunch of, 47 microfarad capacitors, I believe it is. And I wired each of those capacitors to ground. Each Hall signal has its own 47 microfarad capacitor to ground, and that basically smooths out the Hall signal so it won't be interrupted by high voltage and, ground interruptions from the taser hitting the ground pins. Those capacitors are super cheap. Finding these cables is a bitch. I had to get these cables from eBay, and I mean, they're really just jerry-rigged. I would much rather have had just one nice, big, solid 5-pin cable, but I mean, I was working with what I had, and I know there's better cables, but this is just how I did it. And so I used those cables for the Hall sensor connecting into the circuit board there, but then I had to use a bunch of little servo extender cables to connect those all the way down to where the wheel is going, which is like kind of far away over here. Okay, so we have a servo cable there going from the O drive on the GPIO pins, I think 3, 4, 4 and 5, or 3 and 4. Either way, they're all connected down to my receiver, which came with my transmitter. I actually got this transmitter from a wholesaler, a liquidator company for $20, and it came with the receiver and the transmitter. It was a pretty good deal for me. So whenever you see receivers that are have a bunch of channels, just buy them if they're really cheap. That whole mess of O drive is just held in a pencil box that I got from Walmart. And that pencil box, I drilled a bunch of holes into the sides so the cords could stick out real comfortably. And then it's just zip tied onto the ice chest. The whole ice chest is just held together with zip ties. Yeah, I mean, zip ties are just a wonderful tool, and you should just have a ton of those laying around if you want to do this the way that I did it. Most expensive part of the project is probably the O drive. I got the 48 volt O drive. That was around 150 to 160. And the batteries, I got the batteries. I'll put some links from, for pretty much all the components I used. But I got these giant ass batteries for really cheap. I think each one was $60. This one I think was probably $80. So batteries and the O drive were the most expensive components. The ice chest itself was like, what, $50? I had to buy metal. I had to learn how to use a welder. The welder actually failed me super bad. We'll get to that. Hoverboard wheels. Each hoverboard wheel should be about $20 to $25. Get them used on eBay. Just look for hoverboard wheels or hub motors. A bunch of servo cables holding everything together. Oh shit. Here we go. We have 2 RC switches. These RC switches right here, one controls the solenoid valve and one is controlling the flyback transformer. And we have this hose here. This is just a propane hose that I got, which has a ball valve there with a lever on it, and that's connected to a Mr. Heater disposable propane tank 2/4 inch NPT valve. So everything just connects together real simply to make a really good flamethrower. You just have to make sure you use Teflon tape and screw it together super tight. But you don't have to drill any special things in to make that flamethrower work the way that you want it to work. And of course, another pencil box. And in there is just a ZVS driver circuit attached to a flyback transformer. That's a $25 piece of electronics. Put a link to that too. You can see that's just connected right here. And behind that, but I have just wires essentially going down to this solenoid valve. This is a 12 volt solenoid valve here. And that is attached to the propane hose. And so when I hit a button, so this one's for the taser here, and then this one will open up the solenoid valve and shoot propane out, and that will basically be the flamethrower operation. I also mapped this controller to work completely off this button here. So if I hit this button, it will activate both the flyback transformer and the solenoid valve at the same time. I found that the pressure of the propane is actually a little too high to perfectly ignite every time, so I just kind of do both manually. But that flyback transformer's output is attached to 2 nails here. There we go. Those wires are just connected to that nail there through a piece of PVC pipe. That propane valve Actually, the solenoid valve terminates into an additional ball valve that has a little brass regulator here that goes all the way from off to full flow. So you can regulate the amount of pressure coming out of this solenoid valve with this little twisty ball here, and that will shoot out into this PVC pipe wrapped around these two nails, which creates that high voltage arc that ignites the propane. So if I haven't lost you yet, so here's where all my battery connections are. So on all my battery connections, or for my little ones anyways, these are XT60 connectors. I just wrote with Sharpie on them what each one is supposed to be. So this one is solenoid, so I know that that one needs just a 11 volts or 12 volt battery. This one is igniter, which goes to the flyback transformer. So I'm going to put a 22 volt battery on that one. And this big ass one is an XT90 connector, and that one goes to power the whole system. So let's plug this stuff in. Doesn't really matter what order I plug any of this stuff in. It just all has to eventually be plugged in. Always want to turn the controller on before you plug in the machine. And we're on. Should be able to drive it around now. And for the Flamethrower, I just use these little $3 green propane tanks. They work great and they last long enough. I'm not like, constantly shooting flames. It's just like kind of really for a wow effect. You're not trying to set people on fire or anything. So these work great and they're only $3. Expendable little propane tanks. So pick those up. So that is a flyback transformer. Oops. You gotta be so careful with these darn electronics. That stick is so sensitive. It will just smack. I mean, this ice chest is, a solid. Geez, I gotta put both hands on it now. It's a solid, I don't know, I want to say 30 pounds at least. Like it's not a small thing. And this controller, the way that it works, for some reason, like the signal, it's always just slightly off, like it needs to be trimmed frequently. I don't know if that's because of the controller itself, or I don't know how to explain it, but you've got to keep your thumb on this stick and you've got to be really careful with where it's going because you can smash into your ankles super quick, really easily. And I have ran over some feet with this and it's not a comfortable thing to do. I was going to use capacitors on that to make it a loud taser, but I found that with the capacitors, it just was not igniting the propane as reliably as just a solid plasma arc there. And if you can hear it, that is the solenoid valve opening and closing. So what I'll do is I'll spark that, then open the propane, close it, then turn that off. And if I just hit this one button on the back at the same time, like I was telling you earlier, it does both at the same time. And that would be really cool if it worked the way that I wanted it to. Maybe I can work on that in the future. Maybe the nails have to be out further. I'm not sure yet. I'm still working on that. I don't have the propane tank plugged in right now because I don't want to set myself on fire. And I'm inside my garage at night, and so I'll show you more about that later. So there you go, pretty long and boring video about my ice chest, but if you were trying to build something like that yourself, maybe you have a little bit more insight now on how it's done. You can watch my other videos on the subject, or you could watch my race and day with William Osmond, which was a whole lot of fun. Definitely a lot more fun probably to watch than this video. That video should be coming out pretty soon, maybe sometime in the next month. It's all done. It was a blast, but we just have to do the editing. That's the hard part. If you have any questions, feel free to ask them in the comments. I would be happy to answer them. This was definitely the most challenging project I've ever worked on as far as, robotics or remote controlled stuff. It was super fun. I learned a ton of stuff. Ooh, and holding together the frame, I totally almost forgot to tell you about it. Originally, I welded all four of these corners together, but you'll see what happened to that in the video. So now I just drilled through it and it's just held together with little quarter inch bolts. I can't really show you that in this video because it goes through those wheels, and I don't want to pick this up right now. Maybe I'll show you that later. But if you have to do something like this, just drill through the metal and hold it together with bolts. It works better. And mounting the wheels, it was probably also one of the hardest things I had to do. Let's see if I can get in there. What I did to mount my wheels, you can see in there, some light, there we are. So I welded on those little, I cut some square things out there, little pieces of metal, and then I welded them onto the other metal, and then I drilled some holes through those little squares, shoved those wheels through, and then I basically keyed them in with another bolt. And so they're held in with bolts, just like by friction. So I didn't do anything crazy with that, but it works really well. So that's how they're held on. I hope that's, helpful for you guys if you're trying to figure out how to mount hoverboard wheels like that. It was definitely one of the hardest things of building the sled that this ice chest rests in. Yeah, that's it. Hopefully you watched this whole video, because then that will help my watch time metrics on YouTube and more people will see the video and stuff. If you're around the LA area, leave a comment. If you build one of these carts, I will find you and I will race you. Like the video, subscribe or don't, or whatever, I don't care. If you watch this whole video, then thank you for watching. I'll see you in the next one.